Hey, Mr. Wong. I'm Stefan, and Alistair's here with me. We're doing a question from one of the last questions, or the very last question on the Chapter 7 unit test for calculus. Our question states, a fisherman is hauling in a 50 kilogram net on a 15 meter line. The line is 0.1 kilograms per meter. How much work is done to lift the net? First of all, we're just gonna talk about how much work is done to lift purely the net. That means not including the line. So that starts with using an equation that we learned in Physics 11. So for the net, we're going to be starting with force times distance, which in this case, to find the force, we need 50 kilograms times the acceleration due to gravity, 9.8, and that gives us a weight in Newton. That gives us weight in newtons. So 50, 9.8. That's the force times 15. Obviously 15 being the distance. And that equals 7,350 joules.
The next step is to find the work. Next step is to find the work done to lift the line. So now we know the line is 0.1 kilograms per meter and 15 meters long. So to do the line, we have to integrate from 0 to 15. We have 9.8, our acceleration due to gravity, multiplied by the number of kilograms per meter. The reason we're doing that is we need to convert our kilograms to meter into newtons per meter. Then, that is all going to be multiplied by our length of the line, 15, subtracting x. Now the reason we're doing 15 minus x is because at the very end of our line, x is going to equal 15 and there's going to be no more weight left. So while we integrate that, we're going to be integrating the amount of line left, and therefore, with this whole equation, the amount of weight we have to move on the line. So we throw dx at the end, and therefore we end up with equals 0.98 bracket 15x minus x squared over 2 from 0 to 15. Now we sub that in. Now we solve for that. We end up with 0.98 multiplied by 15 times 15, 225, minus 225, 15 squared, which is 225 over 2, 112.5. Now, 225 minus 112.25 is 112.25, multiplied by 9.8, we end up with 110.25 joules. Now, for the final work done.
Alright, so we got, individually we have the net and the line figured out. The total work done is the amount of work done to move the line and the net added together. So, work total equals 7,350 joules plus 110.25 joules for the grand total of 7,460.25 joules. Thank you.